Bismillahirrahmanirrahim, and this is Gulsum Sharifi, and this is the video presentation assignment. So, as we are assigned chapter 12 of software construction. So, chapter 12 is about fundamental data types. So, in this our presentation, we have three group members: Habiba, Sonia, and I. So, we have divided these topics among us. The first two topics, numbers in general and integers, is covered by Sonia. Floating point numbers, characters and string is covered by Habiba, whereas Boolean variables and enumerated tabs. Today, now I will discuss that. That is of my part. That is in my part. I have to discuss that. And the arrays and the creating your own types. Arrays is also my topic, and named constant and creating your own type is covered by Sonia and Habiba. So let's start. So first of all, introduction. We know that the fundamental data types are the basic building blocks for all other data types. Like in the fundamental data types, we have integer, boolean, string, etc. So in this chapter contains tips for using integers, floating point numbers, and the characters in strings, boolean variables, enumerated types, named constants, and arrays. So some of these are the defined data types, and some are the pre-built data types like integers, floating point numbers, characters, strings, and Boolean variables like etc. are the um, predefined data type, and enumerated type is the user-defined data type. And so, as I told, my topic is about Boolean variables and enumerated types. So let's discuss what is Boolean variables. We all know what is Boolean variables. Boolean variables is a predefined data type which is going to store only two values like 0 or 1. Here it is written variable storing only one of the two values 0 or 1. So um, it is hard to misuse logical or Boolean variables, and using them thoughtfully makes the program cleaner. Now, because we have used many times Boolean variables, now in this lecture I am going to discuss why we have to use Boolean variables, what is its essence, and what if we don't use that. So now the first part is use Boolean variables to document your program. Because I told that we can use Boolean variables for different purposes. So the first purpose is use Boolean variables to document your program. Like like in this example, if you see, if element is less than element index is less than 0, or maximum element is less than element index, or element index is equal to last element index. This is not describing what is the purpose of if statement, whether it is working for finding an this condition is an error condition, or it is the condition for completion, or it is performing something else, because it is not clearly described. So if we use Boolean variables, this problem can be solved. Here I have mentioned that bad documentation. It is not clear whether the purpose of the if test is structured for completion, for an error condition, or for something else. So if we use Boolean variables, it will give a very more understandable view of the if statement, and we can easily understand what the if is going to perform. So the use of Boolean variables makes the purpose of the statement clearer. Like here in this example, we can see Java example of Boolean test in which the purpose is clear. Here they have used two Boolean variables, finished and repeated entry, and they have assigned value of this if element index is less than 0, or maximum element is less than element index, whether it will be whether their answer will be 0 or 1, and it will be stored in finished. And same if element index is equals to last element index. If it is equal, if both are equal, so in repeated entry we will get 1, otherwise we will get 0 in the repeated entry. So here they have mentioned that if finished or repeated entry. so next they will perform some activity. So we can see that by using these boolean variables it is very readable, and we can understand why this if statement is used, rather than in this statement which was not very clearly mentioned what was the purpose of if what it was doing. So here I have written mentioned that by creating the boolean variables finished and repeated entry, you make the test simpler, easier to read, less error prone, and easier to modify. So the second purpose why we use boolean variables is to simplify complicated tests. In the first example it was also we were somehow simplifying the test if condition, because it is not, the purpose was not very was not mentioned clearly, and here we just simplified the condition. So is there is another example of how boolean variables can be used to simplify complicated tests. If we go through this code, we don't know what this line is going to do. We need more attention, and when we are when we have short time, so we most of the time we say we will go through this code when we need it, or sometimes we even don't focus, because it needs more attention. So in this example, if document dot end of stream and not interrupted and min lines is less than line count, and we know that this is something about document and reading something, the condition is like that, so it is more prone to error. So to make this code simplify and more readable, we have to use the boolean variables. Like in this example, they have used two boolean variables, all data read and legal line code. So they have stored some value in this, and they have some conditions like document dot end of stream and not input error. So whether all data read will store 0 or 1, and the second legal line count, it will also store some value, like if this is true and this is true, it will store true one, and if this is false or this is false, or if any of them is false, so it will store false or zero. So here they have used if condition, if all data read and legal line count and not error processing, then do something or other. So we can see that we have simplified the previously mentioned code using the Boolean variables. Here the code was not simpler to understand and to read, but here we know that what is the purpose of this code, what this code is going to perform. So this is one of the purpose of using Boolean variables. Besides this, we can create our own Boolean type if necessary whenever we need. Like for example, in C example of defining the Boolean type using a simple type diff, in C we can we can define Boolean type in this way. And besides this, we can also define Boolean type using enum. See, here it is mentioned enum Boolean true is equals to 1 and false is equals to not true. So as my second topic is about enumerated type enum, so now let's discuss what is enum. We can say that enum is a special class or a type of class that represents a group of constants, that is unchangeable variables like final variables. To create an enum, use the enum keyword instead of class or interface and separate the constants with a comma. So for creating enums, we don't have to write like class like this. We just have to write enum and name of the that data type. You know. So here is an example. With the help of example, we can clearly understand what is enum. It is an example in C, C++, or C. Yes, it's C. In this example, they have created an enum, and here is the type boolean. So in boolean, we can store only two values, whether 0 or 1. So they have created two values, no and yes. And here is another example of enum, that is days. We know in days we only have 7 days, like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So By default, what the compiler does is that the first element is assigned 0 and the second element is assigned yes. Now in no is a constant, no contains value 0 and yes contains value 1. We can explicitly assign value to this um, member of this enum. And here enum days Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. By default, Sunday is containing 0 value, Monday 1, Tuesday 2, Wednesday 3, 4. And if we want to assign Friday some other number, so we can explicitly assign value like they have assigned Friday to 7 and Saturday. So how we can use this enum value is like it is the main function. Here we have to just type enum and boolean because the name of here it is boolean and we use that name here. And flag is equals to yes. Now whenever I use flag stores yes, the value of yes, and yes stores 1. So if I print here flag, so it will give me 1. Thursday will give me 0 1 2 and Saturday will give me 8 because the Friday is assigned 7 and Saturday will store 8. So why we have to use enum types? We can use enum types for different purposes like use enumerated types for readability, use enumerated types for reliability, use enumerated types for modifiability, use enumerated type as an alternative to Boolean variables. We will discuss them one by one. So first of all, use enumerated types for readability. Let's suppose I have created, I am using color, you know, if instead of writing if chosen color is equals to equals to 1, I can write if chosen color is equals to color red because in enum, let's suppose I have made a enum and inside that I have values like color red, color green, color yellow, color blue. And because color red is part of the enum, so it it is storing 1. So instead of writing if chosen color is equals to 1, I can use this color chosen color is equals to color red. So what is the essence of this? It is more readable. Instead of writing chosen color is equals to 1, and in any other place whenever I want to uh, use this, so I have to I have to change the value in many places. So here I don't have to, I just have to use color red. In the book this is also mentioned, it is also discussed, so you can also go through the book. Here it is mentioned that you can see here it is mentioned that instead of writing statements like if chosen color is equals to 1, because here they have they have an enum color in which color red, color green, color blue, and some compilers assign the first element to value to be 0 and some assign to be 1. Now color red in this case has, because it is visual basic, and this color red has the value 1, color green has value 2, color blue has value 3. So here it is said that instead of using if chosen color is equals to 1, you can write more readable expressions like if chosen color is equals to color red, because 1 and color red they are same, but color red is more readable. We know what 1 means. We don't know 1 is red, blue, yellow, what. So if I write color red and I know color red has the value 1, so it is more readable. Okay. And next is use enumerated types for defining routine parameters. Now in this example we can see C++ example of routine call that would be better with enumerated types. Now here is a call to retrieve payroll data, and they have some parameters like data true, false, 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 true. We don't know what these values are, what are these values are indicating to. So instead of this we can use this function enumerated types for readability. Like it is the same, but instead of here data true true false false true, they have used the enumerated types like data data data, and enumerated is current employee, it has the value true. Payroll, it has the value false. Saving plan no deduction, it has the value false. And medical coverage include dependents, it has the value true. So it is more readable. We know that what are these parameters um, indicating to. It is more readable. So in this example we don't know what is true false false true, but here it is more readable. So it is also one of the usage of enumerated types. And now use enumerated types for modifiability. For example, in previous example, as I told you that if you discover a flaw in your one stands for red, two stands for green, three stands for blue scheme, you have to go through code and change all the ones, twos, threes, and so on. Using enum solves the issue. As I told you that they have defined the enum data type here. They have defined the enum data type, color red, color green, color blue. So if I want to change it, I can just replace these. I can change their places instead of just changing the value, because it is automatically it will be assigned some values here. Color red has value 1, color green has value 2, color blue has value 3. If I want to add more values, I can add color yellow, color purple. They will get value 4, 5. I can also assign values to them too, but by default they will get 1, 2, 3, 4, and 5. So if I, instead of this, if I use one is like red is equals to 1, 2 is equals to 1, so I have to go through my all code to change their values. But using enum types, I can only go to the enum type and change their values. So I have to recompile that. It will be automatically changed in overall code. So here is use enumerated types as an alternative to Boolean variables. Here it is mentioned that why you have to. So I will just summarize it. Like we have any functional method, and we are returning true for the successful completion of the method or the code, and false if there is any error or something has happened. So we get confused whether there can be any type of error inside the code. So what type we cannot catch that error. So instead of just returning only true or false, we can use enumerated type as an alternative to Boolean variables. Like we can define an enumerated type with the values status success, status warning, status fatal error. So with this we will understand what has happened wrong inside the code. So this is very good example of using enumerated type. Let's read it. This often a Boolean variable is not rich enough to express the meaning it needs to. For example, suppose you have a routine return true um, that returns true if it has successfully performed its task, and false otherwise. Later you might find that you really have two kinds of false. The first kind means that the task failed, and the effects are limited to the routine itself. The second kind means that the task failed and caused a fatal error that will need to be propagated to the rest of the program. In this case, an enumerated type with this value status success, status warning, status fatal error would be more useful than a boolean with the values true or false. So as I already mentioned, this scheme can easily be expanded to handle additional distinction in the kind of success or failure. The next is check for invalid values. Like in if condition, we used to mention that if this then do this, if this then do this. We can also check invalid values of enumerated types with using if or cases. Like select case screen color. It is an example of Visual Basic. So in C++ or other language that supports enumerated type, we can change this syntax. K is color red, it means color red has the value 1. If 1, then do this. If blue, this. If there is any other value, so print out or display this error. So it is very simple. Besides this, we can use enumerated types for defining the first and last entries of an loop limit. This, this is an enum data type, like public enum country, country first 0, country China 0, England 1. They have, I told you that we can also assign values to these enum values and enum. So we can use these values to initiate, to begin, and for the loop condition. Like here, for I countries equals to country first to country last. Uh, use a currency conversion rate I country, like this. So it is an example of visual basic. It means that we can use the value of this enumerated types to define the first and last entries of an enumeration for use as loop limits. But here there is a condition where we don't have to use where we don't have to assign explicit values to the elements of an enumeration. Like here it is C++ example of explicitly assigning values to an enumeration. Like here is an enumerated type color, and the color invalid first 0, color first 1. Like this, they have assigned explicit value to this. But in this example, if you declare a loop index of type color and attempt to loop through colors, you would loop through the invalid values of 3, 5, 6, and 7, as well as the valid values of 1 to 8. Because the first value is 0 and the last value is 8, so it will loop through 0 to 8. But here we don't have value 3, 5, 6, and 7, so it will also loop through that. So this is one of the limitations to explicitly assign values to um, where to the values to an enumeration, because by default they contain the first contains 0 in C++ and 1 and 2, 3, 4, 5, 6, 7, 8, and if we so the loop will also follow that sequence. So we have to be aware of that. So this is all about the enumerated types. And the next is arrays. We know what is array. In array we can it is a collection of values. It stores more than one array. It is a variable that contains more than one values. We have been using arrays in many programming languages like C++, Java, and many others. So I have only mentioned that what we have to take care of whenever we are dealing with arrays. So we have to take care of these points like this. Make sure that all array indexes are within the bounds of the array. Check the endpoints of arrays. If an array is multidimensional, make sure its subscripts are used in the correct order. In C, use the array length macro to work with arrays. So we will discuss them one by one. The first one is make sure that all array indexes are within the bounds of the array. Like bounds of the array, it means that uh, every array has a bounds from the first index to the last. When we are dealing with the array, we have to make sure that we are within the bound of the size of the array, within the bound of the array. So in one way or another, all problems with the array are caused by the fact that array elements can be accessed randomly. The most common problem arises when a program tries to access an array element that is out of bounds. In some languages, this produce an array. In other, it simply produces bizarre and unexpected results. For example, if there is an array of size 8 and I want to access array and with the index 10. So this is out of bound because the array can only contain uh, 9 values, in which I have already mentioned that the bound of this array, the size of this array is going to be 9 elements, and if I write array and index 10 or 11, so it will give in some languages it will give exception, and some other it will give an expected result. It depends on the type of the language. Second is check the endpoint of arrays. So just as it is helpful to think through the endpoints in a loop structures, you can catch a lot of errors by checking the endpoints of arrays. Ask yourself whether the code correctly accesses the first element of the array or mistakenly accesses the element before or after the first element. What about the last element? Will the code make an off by one error? Finally, ask yourself whether the code correctly accesses the middle elements of the array. So we have to keep in mind that when we are dealing with array, uh, we have to check that whether our code, our logic is accessing the array correctly, whether it is accessing the last element correctly, the first element correctly, second element correctly, because it mostly happens that whenever we apply loops, we apply loop, and we are dealing with array, so we start loop with 0 to, like, suppose to 9, it means the 10 value, and let's suppose I have a loop that starts from 1 to 10, and I inside that loop I have used an array, so I have to make sure that I am accessing the first element of the array too, because if I say array of array, let's suppose here is an array with name array1, array index I am written 1, so array I, let's suppose the loop for loop is using the variable I for the initialization and incrementing the values. So I have to make sure that the first element, the last element of the array is accessed correctly, and also we have to make sure that the end point of the array is mm, accessible to the logic, to the program. So next is, if an array is multidimensional, make sure its subscripts are used in the correct order, because we can use multidimensional array like two-dimensional array, even we can use sometimes three-dimensional array and more. So it is mostly confusing when we are dealing with more than one-dimensional array. So we have to take care of the indexes of the array. Like if we are using nested loop, the first loop uses I, in the inner loop uses j variable is for the condition. So we have to take care whether I if when, what I is supposed to do here, and what is j index, what is their value. So it is easy to say array ij when you mean array ai. So take the time to double check that the indexes are in the right order. Consider using more meaningful names than I and j in case in which their rows are not immediately clear. Instead of ij, we can even use any other um, variable name, more meaningful names, in order to get less error and make it more readable. The next one is watch for index crosstalk. Crosstalk Index crosstalk is switching the loop indexes. How? For example, here it is written, if you are using nested loops, it is easy to write array j when you mean array I. Switching loop index is called crosstalk. Check for this problem. Better yet, use more meaningful index names than I and j to make it harder to commit crosstalk mistakes in the first place. So as I already mentioned that instead of using ij variable names, we can use even more meaningful, more explicit name. That the purpose is clear. By that we can avoid the error of index crosstalk, and we can also make sure that whenever we are dealing with the multidimensional error. So this is all, and thank you so much.